Well, good afternoon, everyone. My name is Lee Hian Kee, National University of Singapore. And I'm happy to host this seminar by Associate Professor Raymond Ghim, who is from the Department of Civil and Environmental Engineering at the National University of Singapore. He is also an associate head in charge of research in the department. Professor Ong's research interests cover pavement engineering and multimodal transport infrastructure and operations. This afternoon, he's going to talk to us about waste plastics on roads, potential challenges, and building a circular economy. So, Raymond, take it away.
Yeah, thanks, Prof. Lee. I will start sharing my screen right now. Okay. Good afternoon, everyone. Thank you for joining the webinar at NUS series. And I'm very honored to be here to actually share with you some of my experience on this particular topic on waste plastics on roads, and in particular, the potential challenges and how we can build a circular economy from a research and implementation perspective. So without further ado, I will just go into the topic proper. So we all know that plastics are important in our everyday lives. And plastics basically boast a huge, unique, and useful set of properties. And basically, we know that they are polymers, long chains of molecules made from repeated links called monomers, and often produced from chemicals such as petroleum. And it can be, the molecular structure can be engineered to present different characteristics, be it flexible, hard, transparent, and opaque. And they are durable, strong, lightweight, water resistant, and relatively easy and inexpensive to manufacture. And in fact, most modern plastics today are made from fossil fuels like natural gas or petroleum. And basically, with new technology, as they emerges, the plastics are also being produced from renewable materials such as corn and cotton. And there are thousands of patented plastics spanning countless sectors. All of them are unique to make them fit for purposes. Now, in many applications, plastics is virtually irreplaceable because it's cheap, strong, lightweight, resistant to corrosion. And most common uses of plastics are in packaging and in building components, such as piping. And in the medical industry, plastic is often the key to contamination and infection control, especially during this time of COVID-19. And syringes, pipettes, gloves, masks used in the healthcare industry often cannot be reused, so they have to be disposed. Now, replacing plastic with other materials is not so simple and straightforward, mainly due to the challenge in finding an alternative that combines all the most desirable plastic properties. Now, biodegradable alternatives may work, but the greenhouse footprint during the production processes needs to be considered for a holistic life cycle assessment. And as such, we know that we will have to live with plastics, and the waste that comes along with plastics. So this brings along to the issue of waste management problem that is associated with plastics production and plastics use. Now, this chart over here on the left shows the increase in global plastic production measured in tons per year from 1950 all the way to 2015. And in 1950, the world only produces about 2 million tons of plastic per year. And since then, the annual production has increased close to 200-fold and reaching 380 million tons in 2015. And this is roughly equivalent to the mass of 2/3 of the world population. And in terms of the waste, the primary plastic waste, such as plastic produced from virgin materials, is expected to increase. Now, subsequently, the plastic incineration, which produces greenhouse gases, is also expected to increase, as it can be seen from this chart on the right. Those that is discarded in landfill show increasing trend, but toxic chemicals in the waste may leach into the environment, and this needs to be studied. And while waste recycling is projected to increase, as seen from the chart, the trajectory still shows that in proportion, there is minimal change if we look at the overall number rather than from a percentage basis. Now, the fact that plastic waste disposal is mainly discarded or incinerated shows that the world still largely operates on a linear economy model, which is also known as a take, make, and discard concept, whereby I use the raw materials to produce the products, but only to dispose it at the end of their short lifetimes. And this obviously is creating a problem with waste. Now, this figure on the left basically shows that the issue of waste is not just a global problem. In fact, the waste generated per person tends to be larger for countries with a much higher GDP. As can be seen in the chart here, the developed countries generally produce higher per capita plastic waste compared to the developing countries. And as such, something needs to be done. In case you are wondering where Singapore is somewhere around here in this region. And if you look at our neighbors, such as Malaysia, Vietnam, Cambodia, Indonesia, they are right down in the region whereby laser pointer is pointing. Now, what kind of plastic waste are being generated? The figure on the right basically shows the primary plastic waste production by polymer type in 2015. The most common plastic waste globally includes, number one, the LDPE, which is the low density polyethylene, followed by the PP, which is polypropylene, followed by PP and A fibers, which are the polyester, polyamide, and acrylic fibers, HDPE, high density polyethylene, and the PET, which is what you see for the plastic bottles like polyethylene terephthalate. So these wastes are being either discarded or incinerated. And where are they destined? They may be thrown to the landfill. And in urban cities, this would be a burden. So how would plastic waste pose a burden to urban cities? Number one, it will place pressure on landfill space, especially in a very highly dense island state like Singapore. There is already a space constraint for cities. As a city get more and more urbanized, there is a highly increase in density for urbanized core, and there will be urban sprawling. And eventually, there will be a pressure on finding space for landfill. And once the space has been dedicated for landfill, from an urban planning perspective, it will create some long-term risk consideration, including perhaps soil and groundwater contamination due to the breakdown of the byproducts of plastics. And once it's buried, we do know that there is no material recovery. And in some cities around the world, landfilling tax may be introduced. to ease the pressure on dumping the incinerated waste to our landfill. Now, incineration also poses another problem because toxic gas are released to the environment, especially during the thermal degradation of PVC. And as such, there is usually a need to invest in costly infrastructure for air quality management. And there are usually legislation on the minimum acceptable level of greenhouse gases to be released to the environment. And this is largely to do with climate change policies. And even so, the residual ash from the incineration process do still need landfill space. So we are back to the initial problem, even though their volume is significantly reduced. Now, if we are not able to do the incineration, or there are so many, there's a constraint on landfill space, what could urban cities or countries do? Some cities may choose to export their waste. Developing countries, now usually it will be exported to developing countries, but developing countries usually may not have the infrastructure to minimize the greenhouse gas production caused by incineration. And there may be mismanaged plastic waste, especially in coastal regions, which can have serious implications to the environment. And it may not be a reliable option for the long term, especially when waste importers such as China stop accepting waste. And this would place a burden on the waste reuse or on actually disposing of the plastic waste or in general waste. Now, should the waste be reused, then there is a need to consider the impact of such waste reuse to the urban environments in cities. For example, recycled materials and the use of recycled materials should be comparable to existing materials over the entire life cycle. This is expected for any new material or recycled material that is going to be developed in this process. And of course, the potential of leaching and the impact to water system or microplastic emission to the air and water of filming needs to be considered. And likewise, any other safety and environmental concerns need to be studied in detail should it be reused. Now, one possible solution is to use plastic waste on roads, and hence the topic of today's presentation. Now, plastics on roads could be used, and it can be a mean to actually divert plastic waste away from the landfill and the expensive incineration process that are at risk of harming the environment, and instead put them into the pavement infrastructure that already occupies the city's lands. So the thing that we need is to find an economical solution to make it work. Now, plastic materials are being recovered in the process and repurposed. And hence, we are trying to create a circular economic model for plastics by generating demand at the end of its lifespan. So in other words, we are looking into the sustainability aspect of this issue. And last but not the least, it increased the self-reliance of urban cities that strongly depends on exporting waste to other cities or to other countries. And additionally, we are using the waste as a resource for infrastructure development. So these are some of the benefits, potential benefits of using waste plastics on roads. Now, traditionally, there are two approaches of adopting waste plastics on roads. Typically, the waste is being collected and then sorted based on the type and cleaned to make sure that there is not much contamination, so that it's suitable for use for construction materials. And then the plastics may be converted to pellets, shredded to about 1 to 2 mm size, or grounded into the powder, depending on the use of interest. Now, thereafter, there are two approaches that we may adopt in road building. First is what we call the wet mixing approach, whereby we add these recycled plastics into bitumen at high temperatures, typically higher than 150 to 170 degrees Celsius, to form a homogeneous modified binder or bitumen solution before addition into the asphaltic concrete mixture. Another approach is to treat the pellets or powder as mineral fillers or dust and replace a proportion of the aggregates that is used in the mix and then mix in the asphalt concrete mixture. Now, at this point, certain methods are actually proposing to first coat hot aggregates with plastics as a potential treatment method as well. Now, in either way, the final product would be a plastic modified asphaltic concrete, and these should be tested for use in pavement construction. Now, past studies on the road, plastics on roads from an academic perspective tends to focus on numerical modeling and simulation. For example, the studies by Liang et al. Actually model the LDPE in a tube test under hot storage conditions for a wet mix, in binder form. The one on the bottom basically shows a review that is done by Wu and Montalvo in 2020 that looks at the possibility of using different plastic type, okay, on asphalt and asphalt mixture performance and their general performance in this process. It's a literature study on this effort. Now, if we are looking into mix design and the test, unfortunately, most studies in the literature tends to be focused on clean or single plastic type and are not really focused on waste. And this is a research problem that is to be looked into. Now, from a translational research perspective, we can also learn from the use of waste plastic on roads from other countries. For example, in UK in 2019, research and trials for real-world tests across 8 localities in Buckinghamshire, Bedfordshire, Cumbria, Staffordshire, Kent, Reading, Suffolk, Solihull, and Birmingham in the UK have been tested using plastics modified asphalt. In Tasmania, a stretch of road has been built using additives, basically wet mixing approach, made from plastic bags, bottles, and toners. These toners are basically in the dry mixing approach. So for the plastic bags, it will be wet mixing, glass bottle, and toner, basically dry mixing approach. In Thailand, they have started some experimentation on plastic use in roads. Indonesia, 700-meter plastic road, where the plastic is melted and added to tar to make roads, have been done in Bali. And in India, which is basically where plastic modified asphalt roads have been used, have been founded, over 100,000 kilometers have been built. Now, one thing is in common for all these trials. These trials that is being done overseas are mainly focused on low volume roads and local roads. And they are not tested on high volume expressways or highways. So basically, most of the research to date and the implementation to date are for rural roads or low volume urban streets or highways, and not high volume highways. And second, there is no study to date on the legal requirement test standards for long-term pavement performance and environmental compliance of plastic use on roads. So this creates an issue whereby in urban cities, there is an outright different considerations as compared to local roads. For example, in urban cities, like in Singapore, we will be concerned about environmental impact. Will these roads with recycled plastics, are they going to pollute our water resources? Are they going to fume? Or are they going to perform as well as the current conventional asphalt mix that we have in terms of structural performance, in terms of functional performance? And hence, in the next few slides, I will talk about the challenges for urban cities in using recycled plastics on roads. Now, despite the past trials or cases or implementations on other countries that I've mentioned, and I've mentioned that they are on low volume roads. So what's so unique about urban cities? The first thing that we think about is that there has to be a waste collection system and a waste sorting system that has to be in place. And for urban cities, it's a little bit more challenging in this aspect. Now, in terms of waste collection, production of virgin plastics is often much cheaper than recycling plastics. And this can make recycled plastics on roads a much more cost-inefficient manner for application. And often, mechanical recycling processes are expensive, and we are not able to sort the plastics efficiently. This is especially so in urban cities, whereby the infrastructure has already been constructed and it is extremely difficult to modify or to create a new waste collection system in a developed urban city framework. And in terms of contamination, plastic waste collected may be contaminated from use and must be cleaned in order for repurpose. So these are some of the challenges from a waste collection point of view. Now, in terms of demand side, waste production is actually a secondary demand. The real demand actually comes from the use of plastic. So we have to understand how the city, local plastics sources are being applied and being adopted in urban cities. And this is absolutely necessary to understand the true potential of recycling. And in an urban city framework, whether is it efficient or cost effective to have a plastic recycling market in the city. Now, once we understand this part, the next part will be to look at the performance issue. Now, long-term life cycle costs to agencies and users should be actually equal or better than the existing pavement that is being built. And in the urban cities, it's extremely difficult because and the concerns are very different from local and private roads, mainly because of legislation and public expectations. Typically, in urban cities, residents tend to have higher expectation on environmental quality, noise, air quality, or even water reuses. So these are very intimate concerns and even safety. And the next one I want to talk about is on environmental health and concern, because workers may be exposed to toxic fumes, even though past research studies showed that there isn't really significant difference. Or when microplastics are broken down and leach into the water sources and ecosystems. So these are something that needs to be investigated. And last but not the least, there may be a lack of incentive or public infrastructure for plastic recycling, which I have just mentioned briefly earlier. Many cities, urban cities, are already very well developed and planned for right from the start from an infrastructure planning perspective. And there is really a lack of public infrastructure for plastic recycling or sorting. Now, without such infrastructure, it's a chicken and egg problem. Consumer will then find that there's a lack of incentive to recycle because there's simply a lack of infrastructure or they are not being placed conveniently. And likewise, business will find that there's no case because there's no use case for that to invest in a recycling infrastructure or to use the recycled plastics or waste for products. And you can see that this will start to lead to a vicious cycle for not doing enough for plastic waste recycling. So how to break this circle is something that's important. Now, in terms of that, then we can look into the opportunities for urban city. And I'm going to use the Singapore context on what we at NUS are doing. So that is something that we are going to talk about. So in terms of the opportunities, the first one we are going to look about is, hey, can we actually learn more about the plastic waste collection, sorting, composition, and the quality for road use? So we all know very well that Singaporeans use 1.76 billion plastic items per year, and yet less than 20% of them are being recycled. Now, other urban cities also face similar challenges. Now, but we should not see this as a challenge. We should see this as opportunity. Now, we can actually study the waste that is generated from a categorical point of view, spatial point of view, temporal point of view, because this actually leads us to understand more about what's being collected. If we know what's being collected, we can then design waste collection and sorting mechanism for circular economy appropriately. And from a long-term perspective, we can also study the implication of the quality of the mix, the long-term pavement performance that needs to be assessed. And this will also lead to building good quality control and quality assurance guidance or standards for the plastic pallets or waste pallets as to be generated for reuse, because now we are looking at providing a use case for investment to come in the circular economy framework. Now, in terms of the asphalt mix design, okay, the first thing we need to look into is on the performance. Basically, it has to be compliant with local AG structural performance and stability performance from a binder point of view, aggregate point of view, safety point of view, urban cooling point of view, and noise point of view. You notice that all these points are key critical issues that any residents in urban cities will be concerned. Safety, noise, urban cooling, making sure that the material will last, it won't fail, it won't give you a rough ride. So there's a whole suite of asphalt mix performance tests that we can perform as shown in this slide. I'm not going to describe them one by one. So these are all that can be done to analyze this. Now, other than that, a lot of things that a lot of people may not have actually studied the environmental aspect. When I talk about environmental aspect in the Singapore context, any runoff, drainage runoff, storm runoff from our roads will go into our water collection systems and eventually be recycled as new water for us to use again. And we need to know that whether that's leaching or microplastic in water, so that we know that such use do not create a burden to our water recycling efforts. So these are something that we need to look into. At the same time, filming during production, laying is important. And microplastics or nanoplastics in air during operation, during production, during laying also needs to be studied. And there's a whole suite of chemical tests and physical tests that can be conducted to analyze this aspect. And the third opportunity that comes into it is after we have the performance, we have the environmental, it passes the performance and environmental specifications. Does these plastics used on roads, waste plastics on roads, can it be reused again? Because now we are talking about a circular economy. So a true circular economy would have recycling content in the recycled pavement roads again. So we need to see whether the recycled pavement roads can be reused and to give the new recycled plastic roads a new lease of life. And in doing so, we need to develop standards. And these would then provide a use case for investments, especially in waste collection, sorting, and production. Now, how are we at NUS doing all this? So this slide over here shows the research roadmap on what we at NUS are doing for waste plastics on roads. So we cover mainly also the demand portion, the design portion, the performance portion, rail test roads, the life cycle cost and specs development, comparison with international benchmarking, and recyclability. So you can see these opportunities that I've mentioned in the previous 3 slides or 4 slides, they are covered in our research roadmap. So basically, we look into demand and collection systems, consumer, producer, collectors, and recyclers' perception and surveys, and how they can affect the entire plastic supply chain and the circular economy. And from the plastic that we collect, what kind of plastics to use? And how do we design a mix using a wet mixing approach or a dry mixing approach? And if it's a single plastic use, how are we going to use it? Or if it's a mixed plastic use based on, let's say, seasonal demand, how are we going to design it? So these are very critical research problems that we are doing right now in NUS. And once we have that, how about its performance? For mechanical performance in strength, functional performance in terms of comfort, riding, safety, and then whether does it cause environmental problem in water, microplastics in water, microplastic in air and filming in air, and also weathering. Whether does it age faster or slower or perform better when aging or worse off compared to the conventional mix. And with test roads that is being produced or constructed, we can then do a life cycle cost assessment and identify specifications. And these specifications is important because it's a use case to lead to the collection and the supply chain, because that is the onus for business to invest in this approach. And of course, to reach true circular economy, we also need to look into recycling. So with recycling, then it will then be reused and retained in the system rather than going to the landfill and so on. And of course, we also do comparison and sharing of best practices with other countries and cities. So the next few slides, I shall show you what we at NUS are doing in this approach. So we have developed asphalt mix using recycled plastics for use in Singapore. In particular, we use the asphalt mix for urban streets and also for expressways. And below shows you some of the procedure that we do. For example, we use binder, put it into a shear mixer, and then we have recycled HDPE or are there any other waste plastic? I'm just using this as an example. And we do a high shear mixing to blend the plastics into the binder at high temperature. And they are being put into the mixer with aggregates and additives and so on to be reused. And once we do that, then we'll be able to produce mix that looks like this, asphalt mix with a percentage of recycled plastics in it. And this mix has to be designed for the optimal binder content and the optimal plastic content that is going to be done. And we can produce the mix using various approaches. So you can see that we can use a Marshall compactor approach or the gyratory compactor approach, which is basically modeling impact or by rolling of the tire. And we can do mechanical tests to make sure that it's complying in terms of compressive strength, tensile strength, and the test methods. So that is the mechanical performance in terms of strength. But not only in terms of strength, we also need to look in terms of long-term performance and safety. So for example, we can do rutting tests as shown in the machine in this video, whereby we subject the asphalt mix into multiple, in fact, 20,000 wheel passes to test whether the recycled plastic modified asphalt are performing as well as it should be as compared to the conventional mix over traffic loading. And at the same time, we could also do friction tests to simulate the friction between the tire and the road surface to make sure that the new product that we are developing or the specification that we are proposing can meet the safety requirement and does not cause any increase in accident. Other than that, we can also perform emission testing. For example, this photo over here shows in our lab that we are actually collecting fumes, microplastics, and other materials, other pollutants that may be emitted from the asphalt mixing process. So you can see that we are collecting air samples from our proprietary procedures that we are developing and extracting the filter samples for chemical analysis and testing for carbon, microplastics, and other pollutants such as heavy metals and so on. Now, from the water perspective, we can also do the same by collecting the leachate from percolation tests, and then up-flow percolation setup is being shown over here on the right. And we can also do density separation. In this photo, we are using polystyrene microplastics from sediments and sands with different density for sodium chloride solution. So these can be done to test for contaminants and microplastics or nanoplastics. And last but not the least, we also can test for recyclability. So our team is also exploring the possibility to reclaim asphalt and the recycled plastic from the developed waste plastic asphalt mix for further recycling. And this includes mill dust, because in construction, we'll mill off the surface and they will come in very fine dust. And whether this dust can be reused or not. And do we need to rejuvenate the binder or add in new plastics or add in new asphalt, virgin binder to it to enhance the performance? And also, does the recycled plastic meet the leaching requirement, fuming, and of course, microplastic or nanoplastic in air during operations and in production? And this provides us the use case for a true circular economy, especially when we have defined standards or specifications. Now, as a concluding remarks, I mentioned that plastics is part and parcel of our everyday life, and waste can be a burden to urban cities if not properly managed. And I've actually discussed the potential of using waste plastics on roads. The challenges of using waste plastic on roads in urban cities I also talk about, and it's not just adding and testing for strength. There's a whole suite of functional performance, safety, noise, environmental in terms of water and air that needs to be considered in using waste plastics on roads. But you can take a look at it not as a challenge, but as an opportunity to adopt waste plastics on roads. And this has been demonstrated through our efforts in NUS to study this potential option. Now, as an acknowledgement, I would like to thank our collaborators who have been with us since embarking this journey on our research on recycled plastics on roads. And with this, I end my presentation. And if you have any questions, I will be extremely happy to answer them. Thank you.
Okay, Raymond, thank you for an interesting talk. I guess we can do offline or online virtual clapping. There are three or four questions now. Are you ready to answer questions, Raymond?
Yes.
Okay. The first question comes from Yu Wei Yin. She would like to ask, in your opinion, will economic financial incentives bring about changes in plastic waste handling? For example, Singapore is on its way to establish a global carbon exchange. Plastic waste disposal leads to CO2 reductions, and the respective carbon credits generated can be sold at the voluntary carbon market. Do you want me to read that again?
Yes, I can understand the question.
Okay.
So maybe I will give my response to Yu Wei this question. Actually, Yu Wei has asked a very interesting question, which is on the financial incentive of plastic waste handling, and also on the carbon credits computation. Now, I will handle these two questions separately. On the first part, on the financial incentive part, now, a lot of recyclers, which I have spoke to in our surveys, have mentioned very specifically that unless there is a very clear use case, it's very unlikely for them to invest in waste recycling infrastructures. And how does a use case come in? Is when there is an actual product actual usable product that could be sold in the market, and it's recognized, and it's able to be used by agencies or by the industry. Only then there is an incentive for recycling and waste handling. So you can see that there's a chicken and egg problem. It's who blinked first. So then this issue is that we are trying to break this vicious circle, which I mentioned earlier, by creating a use case that can be adopted. And this actually, we are just trying our little bit to break this vicious circle. But of course, we will need a whole suite of use cases to make this a viable solution. So my approach is, yes, it will help, but without a use case, incentive has only limited leeway it can go into. Now, in terms of the second question on carbon credit, an important aspect is to do a correct set of carbon computation throughout the life cycle when we are using recycled plastic waste. And this, unfortunately, could not be computed so easily unless we are doing a whole set of experiments. For example, just now I've shown you that we are actually doing experiments on calculating, on actually detecting emission in mixing, emission later on in laying, and so on. And during this process, we are actually collecting carbon emission too. And this will actually help us to have a better understanding on the true carbon credits or that could be generated should we use recycled plastics on roads. So that is basically my two-part answer to Yuwei's question.
Okay, thank you. Now, the next question is from Jeffrey Ng. I would like to ask, is it possible instead of the recycled plastics, but reuse the plastics, are we able to treat or use ultraviolet light to treat it so that we can use it again?
Okay, this is another good question, which asks about the potential of using UV light to treat it. Now, it is possible to treat it, but for use on roads, we still require it to use to wash it. Primarily, it's not because of the some of the contaminants or aspects, but we are more worried about the presence of oils and water in our aspect, because should there be oil and water that is not cleaned properly through washing, it will actually affect the performance, structural performance and functional performance of whatever mix that we are producing. And this actually would lead to what we call a reliability issue in using this product in the field or in implementation. And this will means that there will be a huge cost that's going to be borne by who? Usually borne by the agency or the government to actually adopt this product. So and that's why I mentioned very carefully that we have to look into the life cycle aspect.
All right, I hope that answers your question, Jeffrey. The third question comes from Toon Swan Po. Is it possible to produce permeable roads that can improve drainage, especially for increasingly flood-prone Singapore?
Yes, Tun Xuan, yes, you asked a very good question. Actually, the mix that we are looking at for expressways is a porous or permeable mix. So that is what we are looking into. And yes, and that's why we are extremely concerned about microplastic in water, because we are more worried about leakage or leaching of microplastic into our water resources.
Okay, the next question is from Shriyas Pranav. Thank you for the presentation. My question is, what is the potential of using plastics in concrete or ECC pavements?
Yes, Shreyas, this question is interesting. Plastics in concrete and ECC pavement can be explored, but the same set of tests has to be studied, because in concrete perspective, there is still a need for performance tests, environmental tests, and so on. And of course, the life cycle approach. So this has to be studied in detail. In general, there's a huge potential of it, but from a pavement perspective, concrete roads typically occupy about, I would say, 10% or less from our land space in Singapore. So in fact, about 90% of our roads tends to be asphalt paved. So that's why we are targeting the 90% first.
All right. This is a question from Sue Ann Lee. What are the biggest challenges or reasons stopping the scale up of this technology?
The biggest problem and challenges is that there has not been, okay, for building materials and civil engineering materials, for any products that has to be adopted on our buildings or roads, the first and foremost is it has to be rigorously tested so that it could be put up as a national or specification or standards. And this part is extremely important. It's not just that someone produced a mix or someone produced a design and they just build it and there's no legal constraint. Unfortunately, in civil engineering materials, we have to design things and we have to take the legal responsibility for it. And that is the use case, because if there is no rigorous study, we could not come up with a specification or standards. And without that, the industry cannot produce. So basically, without standards, there's no production, and without any production, there's no reason for investors or business to scale up the technology or even to start off the technology. So that's why I say the use case is actually the key bottleneck at this point in time.
All right, the next question comes from K. Fong Tay. How does converting plastic waste to roads compare to other recycling options, like converting them to bricks, fabrics, fuel, pyrolysis? When should we do which?
K. Fong, you asked a question that is mainly on what I would say the plastic supply chain question. I would see plastic waste on road as one of the many approach that is to reduce the issue of plastic waste disposal. Now, that if we can use plastic waste on bricks, fabrics, pyrolysis to fuel, or any energy sources, we should explore it. And it all forms the entire supply chain or ecosystem of waste recycling, of which road is just one part of it. But whichever part of it, as long as there's a good use case that is viable, marketable, acceptable, and usable, then we should go for it. And in this case, whichever comes first, then that will be good. From my understanding on the energy use, it's possible, but the problem is, can it replace the normal battery that we buy at our grocery shop or supermarket? Is it of that level yet in terms of cost? That is something that we have to ask ourselves. So that's why I would say the cost is very important.
Okay, the next question comes from Soon Po Yap. I can probably answer this, but I'll leave it to Raymond. Can you explain more on the type of plastic recycled?
From our study, we actually explored a few types of plastics, including LDPE, HDPE, PP, PS, PET. But from our study, we also know that we cannot have PVC inside and bromides too. The main reason is due to dioxin. So basically, we do not encourage PVC and any contaminants that contain bromides inside at this point in time. So that is what we have been doing. So that's why the sorting is very important. I hope I answered the question.
Okay, we have a question from Sarah Seed. How transferable do you think your research findings will be to applications in other countries and environments?
Okay. Thanks, Sarah, for the question. Yes, our research finding is actually valid for other countries, except for low temperature condition, because we do not have a freezing condition. So in general, for most countries, will be okay, except for winter condition. In fact, our group has been in contact with other research organizations in the US and European Union, in sharing our findings, also in other countries in Asia. So we do know that where we are standing in our research outcome. So yes, it's transferable at this point in time.
All right, we have another question from Sue and Lee. What are the economics of this use case road production like compared to current road material production?
Okay, from the economics of this use case, should it be comparable in cost? I would say life cycle cost, not the initial cost. Life cycle cost. This would be a possible alternative to actually use waste plastics on roads. Now, when this happens, there's two things that can be saved. One is on the use of the reduced use of virgin binder. And you know, virgin binder actually is tied to the oil price. So that is one thing that we are actually looking into. And the second one is to reduce the use of aggregates. And aggregates currently in Singapore context, we have to export from countries. And the amount of countries that we can export aggregates from is getting lesser and lesser by the years. So these are something that we are trying to create by having more resilience in our building materials production.
Okay, a question from Toons One Pro. Will plastic roads make it easier to incorporate energy generating features into these roads as well? For example, electrokinetic roads.
This one is very ahead of time. Yes, actually, this is something that I'm actually thinking about. And we have to, even for traditional roads, it's already a challenge to have electrokinetic for it to be usable case, because traditional roads, there's already a problem with maintenance. And for plastic use on roads, this has to be even considered. So I would say that this is a research problem that we are looking at right now.
Okay, a question from Peter Chang. What's the weight percentage of waste plastic can be applied in the pavement application?
Yes, for wet mixing approach, it's basically we have tested up to 15% of the binder weight, and we are actually working on dry mixing right now, and we are still trying to pump up the number. But one thing we have to take note is that it's not just increasing the amount of plastics, it's actually balancing the plastic amount, the strength, functional performance, and emissions. Because we found that they are all in, some of them are in conflict from an optimization point of view. So there will be trade-off that needs to be considered. So that's why we need to do a proper design.
Wow. Okay. One question just came in. Mohit Kulkarni. Sorting is important. Did you investigate current sorting technology, which is enough for its industrialization in terms of quality of waste for specific plastic types and contamination, as well as its mass production, etc.?
Okay. Mohit, thanks for the question. Unfortunately, our study is not covering sorting, but yes, sorting is extremely important, because what we learned today is that most of the sorting is done manually, or there's no automated process. So if it can be automated, that would be the best. Or it could be even split right from the source. Like in China, there are many different types of bins. For example, for PET, for different type of plastics, there's one drop-off point for it. Then that will be quite interesting to have. It will actually reduce the cost of recycling. And that's the reason why I say that the infrastructure is important. But at this point, our group does not study it, but we are intending to work with any interested persons to study this.
Okay, I don't know whether there are any more questions, but let me ask you one question, Raymond.
Yes.
You mentioned earlier the need for durability test and also the asphalt mixing process in terms of safety. I was just thinking, because if you incorporate plastics into asphalt, use it for road surfacing, you're going to have a lot of abrasion with vehicles running over the roads, right?
Yes.
Now, this potentially could cause plastic dust to be re-emitted into the environment. So that could be of concern, wouldn't it?
Properly, you asked a very sharp question. Actually, I did not show in this slide, but you asked a very sharp question. Our team is actually developing our own in-house proprietary method to test for this, because there is currently zero standard on this at this point in time. So we are developing a new machine that is capable to study microplastic dust that's generated from the abrasion process.
I mean, eventually, now we have this PM 2.5, right? Particulate matter. We could have plastics 2.5, you know.
Yes, exactly. So that's what we are doing, to collect the air samples as the abrasion takes place.
Yeah, okay. Well, there are no more questions coming from the audience. So I have one more question, perhaps to finish off. there's most of the waste plastic is actually polyethylene in its various forms, right? Basically.
Yes.
So I guess if you really focus on reducing the use of polyethylene, you might have solved half the problem, or maybe 3/4 of the problem already, in a sense.
Yes.
Right?
Correct.
Okay. So just a thought, basically, not really a question.
You're correct on that.
Yeah. Okay. So are there any more questions from the audience? We have something like close to 60 participants. Right? We actually have still enough time. No more? All right. If there are no more questions, then we say thank you to Raymond again for a really interesting talk that's really important, I think, to us, basically. And to all the participants, to all the attendants, thanks very much for showing up and tuning in. We'll see you next time. Thank you.
Thank you.
Oh, wait a minute.
Oh,
yeah. All right. This is just a complimentary
okay.
note from the Tun Chuan Pro. Okay. Okay, thanks.
Yes, thank you.